take a look at example C. We have f of xy equals 2y cubed minus 6y squared minus 18y plus 2x squared minus 4x plus 12. We are supposed to find and classify all relative extrema and saddle points. Classify just means, is it a maximum or a minimum? So let's find all of our first and second order derivatives that we're going to use. First order with respect to x will give us a 4x minus 4. Second order with respect to x and x will just give us a 4. First order with respect to y will give us a 6y squared minus 12y minus 18. And the second order with both y and y will give us a 12y minus 12. And last but not least, a second order with x and then y will just give us a 0. So these are all of the partial derivatives that we're going to use. Now we need to find our critical values, which means our first derivative with respect to x, the 4x minus 4, must equal 0. And also the first derivative with respect to y, which is our 6y squared minus 12y minus 18, must also equal 0. Well, taking the first derivative with respect to x and solving that equation, we will get that x equals a positive 1. Now we have to do the same for the first derivative with respect to y, set it equal to 0, and factor. We can factor out a GCF of 6, and then factor our trinomial into two binomials of y minus 3 times y plus 1, which will give us a y of 3 and a y of negative 1. So this gives us two critical values where we know our x values are 1 and the y values must be 3 and negative 1. Now we have to determine our d value using the critical values of 1 and 3 and the d values using 1 and negative 1. So first plugging in 1 for x and 3 for y into the following. So for the second partial derivative with x and x, we will still get 4 since there's no x and y in there. For f with respect to y and y, we're going to get a 24, 3 times 12 minus 12. And then for the mixed partial derivative of x and y, it will remain 0. Now we'll do the same over here, except x is 1 and y is a negative 1/2. X and x stays the same at 4. But y and y will give us a negative 24. And the mixed will remain 0. So now let's find each of those d values by plugging it into our formula. So d with respect to 1 and 3, we will get 4 times 24 minus 0 squared, which will give us a 96. So here we see that d is greater than 0. Also, our double with x is also greater than 0. So that means we have a relative min, but we have to determine where that value is. We have f of 1 and 3. We need to figure out what that output is. So when we plug it into our original equation up here, we're going to get a negative 144. So we have a relative minimum at the point 1, 3, negative 144. Now let's find the d value by plugging in 1, negative 1 into our d equation. We will get 4 times negative 24 minus 0 squared. So that's going to give us a negative 96. Negative 96. So our d is less than 0. If that's the case, then we know we have a saddle point. So we don't have to look at the f with respect to xx, but we do have to find our output value. So if we plug in 1, -1 into our original equation again, we get an output value of 0. So that tells us that we have a saddle point at the point 1, -1, and 0.